Welcome, everybody, and thank you for joining this webinar in which we're going to go through the anatomy of the major BGP leak that occurred on June 24th of 2019. My name is Craig Lowell, Product Marketing Manager here at Catchpoint, and I'm joined today by Nith Mehta, our VP of Technical Services, as well as Alessandro Improta and Luca Sani, our resident BGP experts. In this video, we're going to take you through the full anatomy of the outage. We'll describe how it was detected, how long it lasted, how it impacted services across the internet, and finally, how you can mitigate the effects of similar incidents when they occur in the future. So with that, I'm going to turn things over to Nith.
Thank you, Craig. Another interesting postmortem of a major outage in the month of June. A second major one, but this one was a little interesting because it touched a lot of different services. So many users from across the world were impacted. The internet is obviously made up of multiple services, protocols, and the end users interact with a lot of different types of services, and this outage touched on a lot of them. We say what you see on your screen right now is the classic iceberg slide, which talks about what the end users interact with, the browsers, applications, and so on. But there's a lot of things behind the scene which really impacts their experience, such as the last mile connections, the CDN providers, third-party content on the page. DNS plays such a crucial role in scenarios like these. Ads, marketing tags, marketing content, BGP, which we're going to talk about a lot, ISP peering issues, and so on. Right, so it's really important to understand or have visibility into each of these elements which the end users interact with, because in cases of these outages, it helps us understand what was impacted for the end users and what could be done to fix it. In a scenario like this is a pretty big outage, so we had to wait on the ISPs and service providers such as CloudFront and others to go back, Cloudflare and others, sorry, to go back and fix these. But these happens on a regular basis, and you really need the visibility into each of these elements. So what really happened? We first saw a failure starting at about 6:35 a.m. Eastern Time or 10:35 UTC. We saw failures across the US, Europe, India, and other Asia Pacific locations, and so on. A lot of our customers are impacted. We saw multiple alerts being triggered. We also saw through our internet tests that we track internally that multiple services, in fact, thousands of them across the world, were impacted. This is an example of how soon Catchpoint detected the problem. This also, I'm kind of trying to make use of the opportunity to understand and highlight the importance of detecting problems as soon as possible. Like I said earlier, this is a wide-scale problem impacting multiple companies from across the world. But this happens on a daily basis at a smaller scale, micro outages, macro outages impacting a specific company, a specific region, and so on. So it's really important that we detect the problem as soon as possible. Catchpoint saw the failure for the very first time at 10:35. When we looked at if it was a wide-scale problem that was impacting Cloudflare, we didn't see any updates at that point of time. But about 27 minutes later, we did see that they were experiencing network issues, and it was indeed a wide-scale problem. So the mean time to detect was literally 27 minutes faster compared to when the service provider updated their status page. Reiterating, the process of resolving a problem involves detecting it as soon as possible, identifying what really caused it, escalate to the respective teams, fix and validate. And that's precisely what Catchpoint does. It gives you a head start, so your mean time to repair is improved by detecting the problem as soon as possible. Before we get into the details and what was impacted, let's try and understand what was the scale of this outage, what kind of an impact it had on the internet. So this is a stat which was published by Intricately recently around a CDN study, the number of customers each of these CDN providers from across the globe have. And Cloudflare in their postmortem study had mentioned that about 15% of the global traffic was impacted at the peak time of this incident. And 15% of the 679,000 customers talks about probably around 90 large, medium-scale enterprises that were impacted. Now, this is just Cloudflare. There was Amazon that was impacted, Fastly that was impacted, Facebook, and so on. So the scale of the impact was pretty huge. We spoke about the different services that were impacted, the scale of the impact, and so on. But let's talk about some specifics. What really happened? We saw some companies such as VictorOps, where there were DNS failures. Users typed in www.victorops.com or any of the portal that they were trying to access, and it was all throwing DNS failures. And a Catchpoint has additional test apps which automatically runs as what we call as debug. So for all those engineers who get an alert, they have all the insights to what really happened. So when a user experiences DNS problem, Catchpoint automatically does a certain DNS test called, in this case, called as DNS traversal, where we actually query each of those named servers, and none of them were up or responding to those requests, resulting in DNS failures. So we spoke about the DNS failures. There are other kinds of problems, and like I mentioned, it wasn't just limited to Cloudflare. This was CloudFront, where some of the content of VictorOps was hosted on CloudFront, and they were not responding. We saw some connection failures. So users were staring at a blank page for a long time, or in some cases, the page timed out. All right. So we spoke about DNS and other problems that we saw in the previous slides. This one is slightly different. The primary contents were available, but one of the third-party providers on the page, or third-party content on the page, OneTrust.com, which also uses Cloudflare, a pretty popular privacy management solution widely used across hundreds of websites, was also impacted. How did it impact the websites which had this content? It loads at the top of the page. It blocks some of the other contents which are important for the page to load. So the users were staring at a blank page for a long time. So we've seen the problems. We've seen DNS and all the other kind of problems, and how it impacted the end users. What you see on your screen is some stats from the real user monitoring of one of our customers who also uses Synthetic to detect the problems, but we're also able to understand what kind of problem or what kind of impact it had on their end user's experience. We saw very high document complete, which lasted for a few hours, and then before it could correct itself. And if there is an impact to the end user, there's obviously going to be an impact to the business as well. And what you see on your screen is again from the same customer, real user monitoring stats. The one on the left side where you see the page views had dropped compared to the previous day at around the same time, and the page views had dropped by almost half of what it normally is. So when there is a drop in page views, all the other critical KPIs that businesses track, such as bounce rate, revenue, all of that were impacted too. So in the previous scenarios, we looked at all the different services that were impacted and how it impacted the end users. But here's where we get to the actual root cause of what really caused it. The snapshot at the top talks about the path visuals when we saw the problem, and the one below is after the problems were resolved. So Cloudflare had literally had to get in touch with the culprit literally at the center, where you see DQE communications, which like caused the BGP leak to happen, and which in turn led to multiple services that were impacted. In this screenshot, what we see here is we were testing from multiple locations from across the US and Canada. The networks that did not go through that DQE ASN were good. They were able to reach the destination, of course, with a little bit of packet loss because the entire network was impacted. But all those that went through the red dot that you see there, the ASN that was impacted, caused a lot of problems for the end users. We'll talk about the details. We'll get into the specifics, and we have our BGP experts on this call who will take over and talk about it.
Okay, thank you, Nita. I'm Alessandro, and together with Luca, I'm going to tell you something more about this leak from a BGP perspective. To get a better view on this event, we collected the BGP routing data from public route collectors, the Route Use project of University of Oregon, the Routing Information Service of RIPE NCC, and the Isolario project of IIT CNR. We read data collected via BGP scanner tool, which is open source. And what we found was that this whole route leak was an unfortunate mix of faults by several players. First of all, DQE communications. DQE was the trigger of the problem. For traffic engineer purposes, they split several routes received by their providers and peers into more specifics, including some networks belonging to Cloudflare, Amazon, and Fastly, but not only. Around 10:20 a.m. UTC, they started to announce them to Allegheny Technologies, which is something that should never have been done. Indeed, the traffic engineer routes should never leave the autonomous system domain where they were created to not affect routing of other autonomous systems, like in this case. Then we have Allegheny Technologies. They received these routes from DQE, and probably they were not expecting to receive them. These routes were nevertheless accepted, since by default the customer accepts every route from its provider, and they were then propagated to Verizon due to a badly configured export policy. Indeed, a customer should never announce to a provider the routes received from another provider in order to not become a transit for the two of them, like in this case. And if it happens, it is likely that the customer autonomous system will become a tight bottleneck for traffic, again, like in this case. Luca, please keep on.
Thank you, Alessandro. So Verizon received the leaked routes and accepted them due to badly configured import filtering. Indeed, a provider should accept from the customer only the routes toward the networks of the customer itself and toward the networks of its customers. But in this case, the networks accepted by Verizon came from a provider of its customer, Allegheny Technologies. And thus, Verizon should not have accepted those routes. But once accepted the routes, Verizon propagated them to its 3,000 neighbors, which also include every Tier 1 networks. And what happened is that some of those Tier 1 networks contributed in spreading the leak. Tier 1 networks are all those big service providers which claim to not require any transit to reach any destination on the internet, and they all peer together, exchanging their customer con. This event showed how some of them, like for example Entity and AT&T, apply tight filters on incoming routes from its peers using a mechanism like peer lock and RPKI validation, while other Tier 1 networks don't do that at all. So about the impact of the leak, we can say that Cloudflare was not the only network affected. Indeed, the leak affected more than 1,000 autonomous systems spread all over the world, including, for example, Amazon Web Service and Facebook. In the end, we can say that there is not a single root cause. We can for sure identify the trigger, but every of the players described so far contributed somehow to spread the leak. What we can conclude from this analysis is that there is the need to strengthen the filters on the key players to avoid spreading the routing anomalies caused by mistakes created often by small players. And we can say that in such a complex and heterogeneous environment like the internet, those mistakes cannot be avoided. Back to you, Craig.
Thanks so much, guys. So as we mentioned earlier, the complexity of the digital architecture that everyone relies on these days really necessitates a change in the way that we monitor our digital services. 10 or 15 years ago, when the majority of architecture was managed in-house, it made sense to focus on monitoring that first-party infrastructure first. But now with so many components outside of your control, it's crucial to monitor the end-user experience first so that we can catch issues and then dive deeper into the specific layer of the digital delivery that's actually causing the problem. That allows us to then answer key questions like what impact it's having on the end user experience, what effect that end user experience has on your business, and ultimately what the root cause of the issues are. So to get that all-important end user perspective, Catchpoint allows you to test from every major continent and on every major ISP in the world. So using these locations, Catchpoint also provides 20 different test types that allow you to then drill down into the specific layer of the application delivery so that you can detect and isolate the root cause quickly and efficiently. So that does it for us. Thank you so much for watching. And for more coverage of this incident, please go to catchpoint.com and navigate to our blog.